So guys, I just mentioned something to you. I gave you some salt and said these salts are basic. For example, I said baking soda is basic. And some salts are neutral, like table salt is neutral, is neither acidic nor basic. And some salts are acidic. For example, ammonium chloride is acidic. So we want to show you how to find out whether a salt is acidic or basic. For example, I want to look at potassium nitrate. Potassium nitrate, is this acidic, basic, or neutral? So guys, do you remember that acid and bases react together, they make salt and water? So can I say salt, this is a salt, this is a salt, is product of acid and base reacting together. Let's say acid and bases are parent, let's say, of this baby. So if I want to see what are the acid and bases which make this salt, all I have to do, realize that this salt is composed of two charges, positive charges, two ions, positive on K plus and negative on NO3. And then add components of water. Did we say water is formed from H plus and OH minus? So I'm going to add OH minus to K plus, it makes KOH. And then take the negative charge component of the salt. To this add H plus, Y opposite attract. And then you are going to get nitric acid. So this is the acid. And this is the base. If we react these two together, we can make this salt. So these are the parent. It's acid. And this base is your parent of this baby, which is salt. We want to understand, is this salt neutral, acidic, or basic? All I have to do, look at the strength of the parents. KOH is a strong base. How do I know that? Because the metal in this base is coming from group 1A. Remember we said all bases which have a metal coming from group 1A and 2A, they are strong. So a strong base. And if you look at the strength of the acids, you will see this is also a strong acid. So we make a rule. We say if parents of the salt, they are both strong, that means they produce neutral salt. So we say KNO3 is neutral. So how do we know it's neutral? We generate the parents. We look at the parents, which are acid-base. If they are both strong, the salt is going to be neutral as a rule. So that's how you decide whether a salt is neutral, acidic, or basic. Let me do more analysis for you. Let me clean up this. Clean up my board. And no, the question is, are these acidic or basic? Well, let's start this one. I'm going to break down this to the positive ion. I know metals make positive ion and non-metals make negative ion. How do I know the charge of this is -1? You check the polyatomic ion table, which is in the book, page 89, or you get it on the exam. So to the +1 Can I add H plus to K plus? Don't they repel each other? We know opposite attract. So I have two ions, ions of water. What are ions of water? OH minus and H plus. And I want to add water to the salt to reverse engineer to see what are the two acids and bases which make this salt. So obviously with positive, I must add the negative, right? Opposite attract. So I get KOH. So this is the base which made this salt. And then to the negative charge, I must add the opposite, which is H plus. These are components of water. And I'm going to get H2CO3. Now, I need to determine the strength of the parents. So KOH is a base you already know because it has OH minus. And K belongs to group 1A. Sorry about that. But we said metals of group 1A make strong base. So KOH is a strong base. One of the parents is a strong. And then if I ask you to look at the table of the acid and give me whether carbonic acid, this is carbonic acid, the acid in your soft drink, is this strong or weak? The table is going to tell you that this is a weak acid. So now that you have the strength of the parents of this salt, the stronger parent is going to take over. We have a strong base, weak acid, which is a stronger base. The stronger base, a stronger parent define the property of the baby. So this salt is basic salt. Basic salt. So we say, based on this analysis, this salt that we are talking about is basic. KHCO3 is a basic salt, so it's an antacid. I'm going to look at this salt now. Is this acidic, basic, or neutral? Again, I break down the salt to negative partner. Cl, I know, is -1. This is a polyatomic ion. In the table of polyatomic ion, if you check the charge of NH4, the charge is +1. And then I'm going to generate acid and bases which make this salt. That means add water. Components of water are OH minus and H plus. This is positive. Between the two, it will choose to react with OH minus, right? Opposite attract. So what do I get? Let me bring it here. Do I get NH4? OH? Yes or no? Sorry. Go back. Go back. And if I add H plus, this is the H plus, to Cl minus, I get HCl. Now, this is a base. Why is it a base? It has OH. Is it a strong base or weak base? NH4 is not a metal in group 1A or 2A. Obviously, this is a weak base. For the acid, if you look at the table of the acid, HCl, stomach acid, is a strong acid. So between the strong and weak, the which one is going to take over? The stronger partner. So this baby is going to look like a stronger parent, is going to be acidic. So this is an acidic salt. So go guys, please ask a question. I'm waiting for you to ask a question. Anybody?
Hi, Dr. Fard. I have a quick question.
Go.
Just when adding OH to NH4, I guess I'm confused why it wouldn't be like NH5 plus an oxygen atom. Why does the OH remain intact?
Okay, so this is a polyatomic ion.
Got it. Okay, that makes sense.
Yes, and polyatomic ion, they are like a family. They always stick together. They never change the structure. They keep the structural integrity.
Okay.
So NH4 remains NH4. It's never NH5. It never becomes NH3. So when you look at the table of polyatomic ions, make sure they keep their structure like a family. They stick together. They don't change the structure of the polyatomic ion.
That makes sense.
Great. Thank you for your question. Anybody else? All right. So we can say some salts are neutral, some are acidic, and some are basic. And this is what we discussed. We already discussed this. Use this rule. The rule is the stronger partner from which the salt was formed determines the property of the salt. Another word, salts from strong acids. And weak base, they will be acidic. Salts from weak acid and a strong base, it would be basic. And salts from a strong base and a strong acid, they would be neutral because there is no stronger partner. So that's a general rule. We give you a salt, break it down to the parent of the salt, acid and base. Simply find the stronger partner. That defines the property of the salt. If they're both strong, the salt is going to be neutral. Let me go to the next slide. Go, guys, just do this one. Just do Li2CO3. Let's see who is going to get it first, and then I'll explain it to you. Let's see who is the first. Shall we do this together? Shall we do part A together? All right, Elizabeth, you got it already. Good job, Elizabeth. Oh, wow, good job. More people are getting it. So guys, if I were to find out the patterns of this salt, wouldn't you break it down from here? CO3 is a polyatomic ion. You look at polyatomic ion. Good job, you're doing good. -2. So we have got CO2 -2 and lithium +1. And there is 2 lithium +1. And then this is positive charge. I have to add negatively charged of OH. There is 2 of them. I add 2 of them. So you get lithium hydroxide, 2 lithium hydroxide. And this is negative charge. To the negative charge, I have to have the opposite charge, which is H+. It has got 2 negative charges. So I add 2 H+ to have a neutral structure. That's carbonic acid. Now this is the strong base. This is a weak acid. After checking the table of the acids, the stronger partner is going to take over. So the salt is going to be basic salt.